So what we're going to talk to you.
You gotta stay for questions.
Definitely stay for questions. So what I'm going to talk to you today about is what we do in operations, and the fundamentals pretty much haven't changed since they were laid out for Mercury, Gemini, Apollo, but some of the ways we do things, because the vehicles are different, have changed. So we'll go through some of that. So what do we do in mission operations? Basically 3 words, we can sum it all up and I can walk away. We plan, train, and fly. Planning, we get the requirements from the program office, and about 1.5 years out, as Pete said, we start working to design the mission, plan the mission, and as a lot of people know, a lot of them is highly complex with the different vehicles we have. Of course, the shuttle planning is a lot different than the station planning, where a shuttle goes up 10, 14 days, comes back. So we have to do a lot of things different than we do with station. Station we have time to plan out, and we do a lot more real-time planning in the short term with the station. And the failure analysis is what we do as well, real-time. It's different for a shuttle. With the shuttle, everything is very timely. Since we go up, come back, we have to solve problems right away, fix things, because we can't get up there, and it is coming back. Station, we're not coming back, so we have to be able to solve problems in a little bit longer time. The only things we need to really worry about are the emergencies, and it has been a big paradigm shift over time, and we'll get to that a little bit later. But really, and then we train the crews. So from the start of the mission, train them for everything they're going to be doing, and then we fly the actual mission. And we'll get into some of the specifics in the training and planning in a little later on. So where does mission operations come from? We have 50 years roughly of developing and executing human spaceflight missions. Again, started back with Chris Kraft, Glenn Lunny, and they've laid a great foundation for what we do. And really what we do is the boring stuff. We monitor, right now with ISS, we monitor just the core systems, and we do the EVAs and robotics. We don't get to do the cool stuff with the floating bowling balls and get to see all the cool research. But we basically keep the ISS up on orbit and keep the crew safe. But as I said earlier, the operations now are a lot different for each vehicle. Shuttle, as I said, we have to respond to failures quickly. It's coming back. ISS, we have a lot of time. I'll tell you what, some of you know, when we first started flying ISS, from the control center standpoint, we operated a lot like the shuttle. If we would get a little bit flip, we would beat it into the ground immediately. And we've learned over time that, you know, we can step back if there's not a fire, not a toxic atmosphere, or lost attitude control. We can take our time. And we're going to need to do that for future. And as Pete mentioned, the ISS is very command intensive. It takes a lot of care and feeding. So we need to work on ways that we can build systems that can take care of themselves, that are more autonomous, because we send tens of thousands of commands just to keep calm to the space station. So if we're going out from an operational standpoint in the future, we're going to need to have a lot more. I mean, we've learned a lot about autonomy at the station, and we've learned that we need to get a little better about some of the autonomy, as well as we've had the growing pains with the ECLS systems and some of the other systems, but we are learning from those, and we're learning a lot of lessons, and we operate differently now than we did before. One of the challenges I think we're going to have from an operations standpoint is we will not have the capability to return the hardware like we do now. So we're going to have to, the hardware is going to need to be more robust for us operationally. And we're going to need to figure out how to do failure analysis on orbit. Because currently, we really rely heavily on the shuttle and to bring stuff back so we can do failure analysis. And we're going to need to figure out how to do that up on orbit. And in the future, with the, like we talked about the comm delay, and the crews are going to be gone for a year or more, they're going to play a much bigger role in the failure response and the on-orbit resolution to anomalies, where they rely heavily on the ground right now. I mean, we take it for granted how much or how quickly we can talk to the crew and respond to their problems, and they get responses from us. So it's going to be a big paradigm shift going out past or outside of low Earth orbit. And as Pete said, we're getting into starting to use the ISS for looking at things we can do to further go to Mars outside of low Earth orbit. So we're coming up with the iStar, and Pete gave you a great talk about the iStar. And from the MOD perspective, people have been talking, we've had a couple people involved in iStar further out, but really for the past couple of months is when we started to get into this. Really February, I guess, was when we started to get into it and start doing our planning and our training and getting ready for our execution of our simulation. So what have we done with iStar? Well, we're working with Pete and other folks to determine what kind of DTOs we need to have. If we've already got DTOs planned that aren't exploration DTOs, we're looking into those to see if they have potential iStar application, and we can actually take something from them. We've got folks right now that are looking into analogs, again, with things that we already have planned or we're getting ready to do. And they're digging through previous mission data and tasks we've done on missions and seeing if there's things that we can apply to leaving low Earth orbit. And we're helping to develop the candidate DTO, ex-DTOs, for the 30-day iStar exercise. And the big thing is, as Pete said, we're getting ready to do a simulation, 7-day simulation. So we're working to scope that simulation, and we're trying to get about 35 hours of the utilization time currently from the crew. And we haven't been able to do as much utilization as we want. We've been spending a lot of time with maintenance and other things, exercise. So it's going to be a challenge to try to get some of this time, but we're working to get that time, and then we're going to perform the simulation, but we're going to try to continue any what we call critical utilization activities, so we won't disrupt any of those. And we're also looking at what kind of routine operations do we do daily that we can use that will meet the ex-DTO requirements. And like Pete said earlier, one of the big things that we do is planning. We spend a lot of time planning the cruise days. We plan them down to every minute. It's different than the shuttle. We've learned from the shuttle. The shuttle, their day is planned, and they pretty much stick to the plan. With the station, we end up changing the plan a lot. And we do the 7-day out. We plan all the way down to the real time. We're planning on console and changing their day. And so when we actually leave and go further out and the crew is more on their own, we've looked at some autonomous planning tools, and we're evaluating those to see which ones we want to use in the DTO. And you'll actually hear more about that. I believe Jerry Miller is going to talk about the autonomous planning tools. But that would allow the crews to actually plan their day more, and it would take the ground out of it. I mean, the ground would still be involved, but they wouldn't be as involved. The crew will be able to say, hey, they want to do a certain task, and the tool built into it has all constraints as far as the power generation, life support, daylight, anything they need to know. So that would help them out a lot. So we're looking at some of the tools we already have, trying to use those as part of the iStar exercise, and hopefully that'll help them out. As I said, we train the crews for all the operations on board the station. We do all the EVA training. And currently, one of the big differences for the shuttle is we train the crews to do what we call task-based training. Well, task-based training, as you know, is you teach them how to perform a specific task. So if you have to go outside that task, a lot of times we have to uplink changes or new training requirements. With the station, we are doing a mix of task and skill-based, and for long duration, you're going to need a lot more skill-based. So you train the crews in, okay, this is a skill, and they'll be able to broaden it on their own while on orbit and learn from whatever the skill is instead of just performing the specific task. So we're looking at, in our iStar training, looking at doing more of a skill-based training. And we've learned on the ISS, as we've had our challenges with some of the maintenance. When we go out of low Earth orbit, we're going to have to get away from the ORU-based maintenance concept, which we have now, because we're not going to have all the spares, not going to have all the upmass and the capability. And we've actually been going to the component level when the crews have been changing and working on some of the cards and MDMs and other issues we've been having on orbit. So we're going to have that capability from an operational standpoint when we go out to Mars and beyond. And actually that's been a very interesting shift for us. It's required a lot of I guess more time, and well, it's just been very challenging for us since it's a component level instead of the ORUs. Integrated simulations, we're going to perform the simulation. The biggest thing for us is communication lag. We're so used to communicating real time. I think it's not going to only be a psychological effect to the crew, as Pete stated, but it's going to be a psychological hit to the flight control team, because we're so used to solving problems now and wanting to get our answers on board and get a response back and find out how it worked. I think it's going to be a big impact to us. And from this iStar, we're going to do all the training for long duration. They've already doing long duration, but we're going to do the training on orbit with the crew before they go. And then when they come back, we're going to take, of course, all the lessons learned from both the ground teams and the on-orbit teams, and we'll incorporate that into our operations in the future. But, I mean, really, from an operational standpoint, we really are not going to do much different. It's just going to be, as we know of now. We're going to learn. I'm sure we're going to change, as we did with the station, to whatever we need to do to go to Mars. But for the most part, the fundamentals and the way we operate is, like I told you, Sam, is pretty much going to be the same. And then, of course, the iStar real-time simulation. So we are really working with Pete and everybody else, because we just got into this, to try to really define the parameters that we're going to operate by. And we're going to, as he said, we're going to institute a voice delay of about 10 minutes. But like real flight controllers, nobody wants to give up their data. So we will be getting real-time data and making calls on the real-time data. I personally think we should step away and actually have a 10-minute, we should have some people watching real-time data, and we should have a 10-minute outage for everybody. That's just my opinion. Do it for real. We're working on coming up with all the flight rules. As you know, we live and die by flight rules. You're not allowed to do anything, go to the bathroom, eat, unless you have a flight rule for it. So we are developing flight rules and procedures. And again, the 10-minute loss of comm, or I'm sorry, comm delay, when you're writing your procedures, the crew is really going to rely a lot on the systems that are currently up there and the software doing its job, because they're not going to have help from the ground, and it's going to be an interesting challenge, that 10-minute delay. I really think so. Working with the international partners, as Pete said, is a challenge, and we're working to get them on board. Luckily, we let the program do most of that for us. And when we get on the console, it's really easy from a real-time perspective to do something and tell them that's what we're going to do. You know, have patience with us. So, but we're working with them to get them on board, and actually, they're showing a lot of interest in playing along because they really want to help go out further and go out there with everybody. So, they're really trying to help out and play along. As I said, this to us, I think, since we're getting into this brand new, so we're starting to really talk about it and starting to get excited about it. It's really going to be an interesting exercise, since we are just so used to babysitting, and you know, the crews have really relied on us, and we're really going to have to step away from that because they're just not going to have us there. The vehicle, I mean, the people that are out there that are designing and developing and doing the things to get us going out further, the vehicles really need to take care of themselves, the autonomy needs to really be there, and it would really help us out, I'll tell you that. But one thing I did put on my first slide that we all need to remember is it's one of our fundamental basis of mission control, is to always be aware that suddenly and unexpectedly we may find ourselves in a role where our performance has ultimate consequences. And that really is not just for the men and women that you see on TV sitting there watching the crew, watching the station, but that's everybody that writes any code, builds any hardware, does any science. I mean, all of it. We all play a role, and we all have unexpected consequences if we don't do our job right. So, but that's what we do in operations. I mean, the boring stuff, we don't get to do the fun stuff. Thank you.